Hi, my name is Alex, and this is my project on the 2-bit adder. Firstly, here we have the circuit diagram indicating your 4 different inputs. Your first binary number, which is B1 and B0, and your second binary number, which is A1 and A0. These each are switches controlled by 2 per binary number. In this circuit, you have 3 full adders and then an OR gate to complete the entire circuit. Firstly, as you can see down here, the switches are connected to ground, which has a 10K ohm resistor in between each one. Firstly, the B0 switch leads into the first full adder, which has an XOR gate and an AND gate. The BO leads into the XOR gate and the AND gate, and then the A0 leads into the same XOR gate and the same AND gate. This first XOR gate leads into your first output digit, which is going to be S0, which is an LED that is grounded with this 470 ohm resistor. The output of the second of the AND gate in this system leads into another full adder, which we will cover shortly. The B1 switch leads into a second full adder, which has an XOR gate and an AND gate. The B1 switch leads into the XOR gate and the AND gate, and the A1 switch leads into the XOR gate and the AND gate. The output of the XOR gate leads into the third full adder, with it leading into a XOR gate and another AND gate, and the output of the second AND gate leading into the XOR gate and the AND gate. The outputs of the XOR gate leads into a LED, which is again grounded by a 470 ohm resistor that indicates your second sum digit, which is also represented in binary. And the output of your 2 AND gates in this situation lead into an OR gate, which converts into an LED representing the carry digit, which then again is also grounded by a 470 ohm resistor. This circuit diagram is built on this circuit board with the dip switch over here. So you have your different inputs, and then it'll give you an output. Each of these is grounded by a 10K ohm resistor, and it is also powered by the power rail. The positive leads into each of these chips, which powers each chip, along with a negative lead. This allows the output of the chips to be any variable, either on or off, allowing us for the circuit to work. You have the XOR chip here, the AND chip, and the OR chip. And then these are your output binary numbers, and here's your power supply. This is the custom PCB designed by Mr. Darcy. This is a fantastic circuit that demonstrates the workings of a 2-bit adder in a nice, sleek, formatted case that is connected to a 9-volt power supply. You have 2 dip switches here, and you have mountings for your chips, which involve a XOR chip, an AND chip, and an OR chip. You can have your inputs over here indicated by your red LEDs, and then you have an output, which is A plus B, which is input A and input B. As you change your values, your input will change. As you can see, 1, 1 will have the result of 0, 1, 1 in binary, which can be converted to 3 in digital numbers, which is the same result as here. Now, if we add another bit, which is 1, 1 plus 0, 1, you get the result 1, 0, 0, which follows all logic in addition circuits. This is a fantastic way of visualizing the results of a 2-bit adder without all the complication of wires all over your circuit board. In this circuit here, we have a 9-volt power supply and 2 half adders and an OR gate. This completes a full adder. These switches here are the numbers that you're adding together. For example, you could have on, off, off, and they would give you a different result for your output. Each of these switches is grounded with a 10K ohm resistor. Your first half adder is connected to switch number 1 here and is connected to the XOR gate and to the AND gate, and the switch 2 is connected to the same XOR gate and the same AND gate. The output of the AND gate leads directly into an OR gate, and the output of the XOR gate leads into another half adder. This half adder leads into an XOR gate and an AND gate, while you have your carry bit here, which is represented as C1 as another switch, which is also grounded by a 10 kΩ resistor, leads into the same XOR gate and the same AND gate. The XOR gate leads into a red LED, which represents your sum bit and is grounded by a 470 ohm resistor, while your AND gate is connected into the OR gate and leads into another LED that is also grounded by a 470 ohm resistor that represents your carry bit. The circuit shown below is your full adder circuit with your 2 binary inputs, and you also have your carry bit that you can add into the equation as well. Each of these is grounded by a 10 kΩ resistor and is powered on the power rail by an orange wire. There are 3 chips on this board: an OR chip, an AND chip, and an XOR chip. The outputs can be seen over here with 2 red LEDs connected to the power rail by 2 470 ohm resistors. As you can see throughout the circuit, each chip is individually connected to each other following the circuit diagram and completes a circuit that will have an output of the addition of these 3 numbers in the circuit.